Nirvana, Emoji J, what's up? Beck, what's up? Ryan, how are you? Welcome, welcome one, welcome all. Thank you all so much for being here. Welcome, welcome one, welcome all. Thank you so much for joining me. Hey, what's going on, guys? How is everyone doing today? Welcome to Weird Science. I'm your host, Mike F. Bell. If you're just joining me, we are going to be talking about a few things today, doing some science and having a good time. Can everybody hear me okay? I just want to make sure. Sound check, mic check. So what we got going on here is the SpaceX Starship. It is awesome, fantastic. I will be showing you that. SN9, they had, that's serial number 9, they had a test flight. So here, let's take a look at it. They had a 10-kilometer test flight. What's up, Kalia? There we go. Something wrong. Yeah, look at that. It's blasting off. It's working really well. It's going against gravity. 3 Raptor engines are going off right now. It is the SpaceX Starship. And, you know, like Nicki Minaj says, starships were meant to fly. And then look at this. It's like, yeah, this is the one. You're going to see what was going on here. If this is footage, they're different. Yeah, for sure. And if you're all just joining me right now, be sure to smash that favorite button. Hold down those hearts. If you're holding down the hearts, it helps me trend and do all kinds of good stuff. So please do that. What's up, Artemis? Artemis! I cannot spell or read. So we got the SpaceX Starship. It's doing a 10-kilometer test hop. This is the footage from the other day. It was a good test. It actually flew on 3 Raptor engines, and you'll see what's going to happen. It was unsuccessful, long story short. So it got to apogee, and like I know once it gets a little bit further along, they're gonna be lowering down more miserables. What's going on, dude? How are you? So they're gonna start shutting down these engines, so one at a time, and what you'll see is it'll look like a big cloud of smoke. You'll see that. You'll also see the rocket will tilt. It's going to do a belly flop eventually. And thank you for that favorite. So what's going on is, there we go. I think that was one of the engines going out. They use 3 at the beginning, then they cut down to 2 engines, and that's before going to 1 engine and finally cutting them off completely. Once they reach apogee is the highest point of their trajectory. So it's still climbing. Unfortunately, I don't have the telemetry data. Otherwise, I'd be able to tell you exactly how fast, how high, and all that kind of good stuff. But it is still cool. So now I think they are down, possibly down to 1 rocket. Can't really tell. There we go. See that smoke that's coming through? It's that stage shutting down. Sorry, move that over a little bit so you can all see what's going on. And it's gliding. Pretty awesome. Kim Possible, how are you? And see, it's all just gliding on those fins. It's pretty impossible, but possible at the same time, because and what's going to happen is, it's coming back. It's starting to rotate. Yeah, it's coming in at a weird angle. They're not ready to counter their with a retrograde firing of the rocket. See what's going on? It's like slowly leveling out, and then it's going to flip back up. And then those engines turn on. But that obviously does not go as planned. And if you're just joining me, this is Weird Science, and we're taking a look at SpaceX's Starship. This is serial number 9, or SN9 as it's referred to. Very soon it's going to be exploding. Here we go. Look at that. Look at that. Oh! And boom. Explosion. So that's incredibly it's like, good thing there's not people on there, right? It's just all test phase right now. It's just so anyway, let's go on to our course of action. What's going on today? We're going to be, we talked about, we had our introduction, starships were meant to fly and then crash into the ground. That's going on. So now we're on to our first experiment of the day. Actually, not first experiment. We're going to talk a little bit about gravity. gravity is no, the launch wasn't from, it was from yesterday, but it exploded. They already have serial number 10 ready to roll out. You might have been able to see in the pictures, it was right next to the one that they tested today. So it was neat. So we are dealing with gravity today. Gravity is something that SpaceX deals with, and you need rockets to overcome gravity. What is gravity? Well, gravity is something that exists because of mass. The more mass you have, the more gravity you have. The bigger the mass, the more stuff weighs. So you might see in this below me, if you weigh 100 pounds on Earth, you'd weigh various different weights at the different planets. So if I know that the gravity on the moon is 1/6 that of that on Earth. So if I was 1/6 my weight, let's see, so I'd be about 70-ish pounds. So that's pretty cool. Now, a neat thing is mass and gravity. Gravity affects mass the same. No matter the size or the object, or it doesn't matter what it is. And what I'm going to show you is some stuff. You might have heard of, or even seen it possibly, the experiment where Neil Armstrong drops a hammer and a feather on the moon. If you haven't seen that, I'm going to be kind of reproducing that. So we'll take a look at that in just a moment. If you're just joining me, be sure to smash that favorite button. I'm Mike F. Bell, and this is Weird Science. I do physics and chemistry experiments and just try to bring an understanding to all the different science topics out there, make them easy to understand. So let's go ahead and take a look. Experiment. Okay, so here what I have is I have a container with stretched over fabric, and then I have some ball bearings, and ball bearings, and this kind of simulates how gravity is. Gravity actually warps the space-time of the space-time of our universe. So what that's actually doing is kind of like, here I got a lead ball, right? So everybody hopefully can see this lead ball. Okay. And then that actually pushes down and causes a disturbance in the space-time, right? So like that. Now, if I take another bearing and roll it, see, it kind of, it's just, you can see how it kind of curves and makes things go into orbit. Everything is like a circular orbit. So watch this again. So if I press this down and then, and that was a little bit too fast, but not a big deal because, yeah. So gravity warps this space-time. And that's what I was hoping to show with that experiment. And I appreciate favorites. Thank you so much for the favorites. Yeah, we're taking a look at gravity and the different aspects of it. So next, what I wanted to, actually, you know what? Nah, that's too big. Okay. So here we go. Here we go, here we go, here we go. No. So I've got a two little ball bearings. One's lead and one is stainless steel. You may maybe look at that one. Anyway, gravity is a cool subject to study. And you know what's neat? Everything falls at the same rate. So these two objects that I have, this one is lead. It's much heavier and it's bigger than this stainless steel bearing. Now, if I drop these, they drop at the exact same time. Like, it does not matter. Objects will drop regardless of their mass. They're going to fall at the exact same time. Gravity has always the same influence over things. So, one way to show that, actually a feather will drop at the same rate as a piece of metal, right? Okay. But that's only in a vacuum. So not everything drops the same way. So here we got something. I have a hammer. Okay. And if I was to drop this hammer, what do you think would happen? Here, let's see if I could pull the camera around this way so I can. Okay. So if I was to drop this hammer, what do you think is going to happen? Yeah, if I drop it on my foot, yes, I'll hurt my foot. But if I just drop this hammer, will it go down like that? Or what will happen? What will happen? I mean, this hammer wants to like go like that. So I don't know. Do you think it's going to fall on the head first, or do you think it's going to? Well, let's just see. Let's take a look at this. And frame it. Okay, ready? And it falls straight down. Straight down. So even though, here, let's maybe look at it differently with a different camera. Okay, here's a side. Okay, so, oops. Ready? Falls straight down. Straight down, because gravity, like I said before, it affects things. Hold on one second. I gotta adjust this camera. It's like a little bit blurry. Sorry. There we go. Okay, so that will fall all the same. Everything falls the same. And here's something cool too. The neat thing. Let's go back to this top view. And here I have a vacuum chamber. And if you could see right here, there's a feather. And there is also a, let's see, swing my camera here. Okay, you can see there's a feather up there and a piece of metal. There's a metal bearing, and what's going to actually be pretty cool is if I do this right, we should be able to take the pressure down in the chamber and drop the feather and the ball bearing, and they should fall at exactly the same time. Because when there's no air resistance, then you are very easily able to there we go. See myself. So what we got? Let's go ahead and turn on the vacuum pump. And now I am decreasing the vacuum, or I'm decreasing the air pressure inside that vacuum chamber. So you can see, I think, hopefully. Up there, whoops. Right. So I'm going to turn this. So up here, there's exactly. It is all about science. So I got a vacuum chamber here, and just so we all know what's going on here, my name is Mike F. Bell, and this is Weird Science. We're talking about gravity today and learning some stuff about gravity. Gravity is all dependent upon mass, or not dependent on mass. Excuse me. Gravity is dependent on mass, but it doesn't affect mass differently. So it all has the same influence on each other. So before we dropped a hammer to see what would happen, and somebody thought it would go like this, somebody thought it would flip around and do whatever, but we saw that when you just drop the hammer and just drop it, it will just fall straight down. If you don't impart any type of moment or spin onto the hammer, then it'll just go ahead and drop. It's like gravity is so important to us and to our well-being. Did you know that humans evolved with gravity? If we did not have gravity, we would be pretty in desperate times, I think. This has been proven with the astronauts that go up to the International Space Station. They're experiencing microgravity, not zero gravity, but microgravity. And that microgravity actually has problems. It causes all types of health issues, whether it be bone density loss, which is like as bad as osteoporosis, or the circulation issues, because normally on Earth, your body is used to all the blood going and getting forced down and then having to get pumped back up because against gravity. But when there's not gravity pulling that blood down, it's going to cause an overpressurization of blood and fluid and everything up into your brain. So it's probably not too good long term. And thank you all so much for the favorites. My name is Mike F. Bell, and we are doing some weird science. We got an experiment here. It's pretty cool. It is a vacuum chamber, and then inside the vacuum chamber, I have a feather and a piece of a ball bearing, and I have it attached to the top with a magnet. So once I remove the magnet, they should all just fall, and hopefully what you should see is everything falls at the same time, because when there's no air resistance, that feather will fall at the same speed as the ball bearing. So let's, here's the top view again. And this is, you see that feather, and then let me rotate this, and then we'll then you'll be able to see everything all at once, hopefully. Okay, there's side view. So we got side and top. Whoop. Okay, here we go. Ready? I'm gonna go ahead and pull this. 3, 2, 1. And if you saw that, that feather dropped like a weight. Hopefully everybody was able to see that. And if you weren't, you could just see it when I rotate this vacuum chamber over. If I flip it over again, you'll be able to see the exact same thing. Okay. See? Yeah. So it's when you take out the air pressure and decrease, make it more like a vacuum. Well, here, I'm going to have to reset this one more time, and then we'll do that. Turn off my vacuum. Hopefully, there we go. No problem. And if you're just joining me, be sure to smash that favorite button. I'm Mike F. Bell, and this is Weird Science. I hope you like doing experiments, because I do this every week. I try to break down the different topics of science and make them easier to understand. I myself have a master's in structural engineering and am a scientist, so it's good being able to bring stuff to you. So let's go ahead and attach this again. There we go. And then go ahead and close the vacuum chamber up, get this back in good camera view. Hopefully we could all see this. All right, so let's go ahead and turn on our vacuum. Let that vacuum down the right? No problem. I totally appreciate it. I tend to think that I'm a little cooler and better looking than Bill Nye, but so we're pumping down this vacuum chamber. And by the way, if anybody spins the wheel, the Octo wheel, and gets the Octo prize, they get to add their name to my name for 1 week. So what's going on here is the vacuum is pumping down this vacuum chamber, and what I'm going to do is I'm going to release the magnet up here, and you should see the feather as well as the ball bearing fall at the exact same time. And if you haven't followed me on my Instagram, now's a pretty good time to do that. Go on to Instagram, follow me, same username as my username, Mike F. Bell. And let's see, here we go. Let's do this again. Ready? 3, 2, 1. Oops. 3, 2, 1. Bam. No, there's gravity, definitely. There's no air. What I did there is I have a vacuum chamber. I pump down the air to make it so it's closer to a vacuum. And then I suspended a ball bearing and a feather to the top of the chamber. And then I released it, and you were able to see that they fall at the exact same rate. Pretty cool. All right. Well, next, what I have here. So that was all about gravity. Now there's something else that we're going to talk about, and that is center of gravity. Center of gravity is pretty cool because you can find the center of gravity of a lot of things. And if, hold on 1 second, do the side view here. Okay, so what I got here is a couple different shapes, and I'm going to show you how gravity, or the center of gravity, can be found fairly easy. So what I have here is, okay, so if we take a look at this triangle, I attached this little plumb bob to it, and you see that this is free to rotate. So if I do that at if I go at every corner and do like that, and then just make lines, the intersection of those lines is right there, and that will be the center of gravity. You could actually balance pretty good. So of various objects, so that was a triangle. So now we have a circle. So circle, of course, it's going to be pretty easy to find the center of gravity. Of course, it's just the circle's center. So again, let's go from here. Whoops. There we go, like that, and yeah, you get the idea. But it is right in the center. The center of gravity is in the center of a circle. What's going on, Bam Bam? Okay, now I got an irregular shape. So this one is a little bit strange because, I mean, it's not a normal shape, but you do the same thing. Every corner and cornered, and then mark it, corner, mark it, and then you get the center of gravity. Okay, so why is that important? That is important because if you don't calculate the center of gravity, things will tip over. Like, you need to make sure that the center of gravity is not higher than outside the perimeter of the area. So other things will flip over. If you get too much of the weight too high above ground, then it's just going to flip over. Pleasure to see everybody. This is Weird Science Wednesday, and I'm your host, Mike F. Bell. We're talking about gravity today, so I hope that you're enjoying this. This is actually some LaCroix. LaCroix, it's the best sparkling water there is. Actually, my favorite. It's limoncello. Limoncello LaCroix. Hey, Mike. If you're just joining us, we're talking about gravity. So, informative so far. Loving it. Thank you so much. I really do appreciate it. Gravity. I hate that show. Yeah, I mean, we need gravity. It's kind of important for us to live. Yeah, for sure. Okay. So, I got some more stuff to drop, of course. Put this out of the way. So, I've got three different sizes. I've got a little ball bearing. I got a plastic ball and then a cue ball. And based on what you've learned so far in this stream, what do you guys think? How's it gonna fall? What's up, Aaron? How are you, sir? The same speed. Yes. Yeah, everything's gonna fall exactly the same. With gravity, everything's gonna fall exactly the same. So it doesn't matter how massive it is. And that's another thing that I just wanted to point out. Mass and weight are two different things. So your mass is always going to be the same. So if you have one mass, you'll be the same mass on Mars as you will the moon, as you will Earth, as you will Jupiter. Like, your mass doesn't change, but your weight does. Your weight will depend on gravity. So your weight times your mass, your weight is equal to your mass times gravity. And that's your force. What about it? What about antimatter? I think that until we have real applications where we can actually prove things in a laboratory, it's just theory. So, three objects. I drop them. They all hit the ground at the same time. Bam. All the same. All at once. And that was like in the vacuum, too. I had the vacuum chamber up here. Drawn to the stream. Well, you should be. It's magnetic. It's probably my magnetic personality, or it could be the fact that I have a big neodymium magnet here. Nah, probably not. So let's go ahead and attach this with some of the magnets. So I got should probably go back to this other view. So I got to be able to see both. Let's go and attach that. Okay. Close that up. Hopefully get this in the camera. Whoops. Okay, so that's the top side, and hopefully you could all see everything. Check my view here. Okay, so let's go ahead and turn on the vacuum. There we go. So I'm cranking down this vacuum chamber, and you'll see that the feather and the ball bearing will fall at the exact same speed. It's because gravity pulls objects, no matter what, the same. It doesn't matter whether it's a feather or if it's an elephant. If it's an elephant and a feather, it will pull them exactly the same speed if it is in a vacuum. But it's because of that air resistance that you have the fluttering of the feather just going back to back, back and forth. So what I'm doing here is I'm cranking down the vacuum, or cranking up the vacuum, making this air pressure get really low. I pay a lot more attention than I did before. Of course. It's like school is wasted on the youth, right? It's like everybody learns so much better when they're older. Exactly, but at the same time, it really is about the teacher's presentation style, their ability to connect with the student and make everything fun. So I hope that you guys are having fun, and I hope you all had the chance to smash that favorite button. I'm Mike F. Bell, and this is Weird Science. I do this every single week at Wednesday at 3 p.m. Eastern, 12 p.m. Pacific time. I hear you. Okay, so let's go ahead and drop this. So see if we can get something cool here. 3, 2, 1. So what are we doing? We are looking at gravity and studying some gravity principles. Did you know that gravity is all dependent upon mass, but when it comes to attracting things towards it, mass doesn't matter. So what I have here is a demonstration set up to show that a feather and a ball bearing will fall at exactly the same speed in a vacuum. Hey, Sean, what's up? Yeah, it's pretty cool. Like, oh, I should probably turn off this vacuum and reset this experiment so you guys can see it again. Go ahead and let the vacuum out of there. Starting to shred my feather. No big deal though. Welcome to Weird Science. Thank you all so much for joining me. And if you're liking what you see, please hit that heart button. Please smash that favorite button. And please donate those diamonds. If you could do diamonds, do it. I think you guys are awesome. And for anybody that spins a wheel and gets me that, what is it, the Kraken or the octopus? The octopus. I will put their name up in my name for a week. So you will get to be up there. What did I do with that? Luckily, I have lots of magnets, so that's a good thing. Whoa. Whoa. Didn't mean to do that. I love science, chemistry, love octopus, dude. Maybe it is the Kraken. I'm not sure what it is, if it's the Kraken or the... But it's really important that people understand and learn science. I'm a scientist, so I really value knowledge, I guess. There we go. Damn it. It's like getting this reset is actually not that easy. And now I'm dropping everything. As so frequently goes when I try to rush. There we go. So again, put that back in there, reset that. Hell yeah, nerds unite because nerds are awesome. Hopefully that is all coming out. Everybody can see everything. And what's up, Wrong Stream? How are you? We're taking a look at gravity. This is Weird Science Wednesday. I'm Mike F. Bell. And you know what? We are taking a look at why gravity makes things fall. Gravity, it's one of those things that's dependent on mass. So the more mass that you have, the more massive something is, the higher the gravity. So if you have the healing power, yeah, it's all pointing at the same thing. Except me, like I'm trying, like the thing is, it's kind of hard. Oh no, gravity, the eternal enemy of women. Exactly. The gravity makes everything fall to earth. Gravity keeps the earth around the sun. Gravity keeps the moon around the earth. Gravity is important to us. The gravity can hold you down unless you have a rocket, which I showed before. There's the only way that we can get to space is with rockets. Yes, it keeps our food from floating away. It keeps you and I from floating away. Mr. All right, so let's go ahead and pump this up again. And we got the vacuum chamber taking the pressure down. It's like we're probably going to go into a new ice age before long anyway. Our climate is in sad state of affairs. I wish certain parts of the Earth experienced different gravitational pulls. Would make traveling more interesting. Actually, the gravitational field is different all around the Earth. But it's not so different that it's like... But you would be able to actually get a different weight. It's noticeable. Yeah, you can actually record it. So there's like different gravity coefficients. The average that everybody uses is 9.8 meters per second squared. Maybe, maybe not. It really depends on how gravity... To play Gravity Song, I'm not sure what that is. Tidal pull from the moon, yes. And the sun. The sun is actually responsible for a lot of it too. It's the sun and the moon both affect everything. It affects our tides. Gravity is important. Gravity is still something that we don't fully understand. We have 4 forces that exist. There's the strong force, the weak force, the electromagnetic force, and also gravity. Gravity is the weakest of them. Not on here. Elon Musk is selling space exhibitions. Yes, I know that somebody, a billionaire, has already booked a flight on the Crew Dragon. Quantum physics is fun, but it's hard to explain. I'm not even sure if it's true. Gravity anomalies explain a black hole. A black hole is when a sun just keeps on getting more massive, more and more suns. And eventually it gets so massive, like so massive that everything is affected by it, even light. So that's why they call it a black hole, because not even light escapes it. Once you go past the event horizon, oh yeah, speaking of vacuum pump, let's go ahead and drop this one more time. Gravity anomalies. Yeah, gravity is something that warps the space-time fabric. So it's interesting. It's really interesting. So let's take a look at this. Here we go. Ready? 3, 2, 1. And that fell really quick, huh? I know Tesseracts are involved with making some pretty complex bubbles. No, actually, Tesseracts, when you look at the extra coordinates of the Hamiltonian system, like then that's where you start getting into Tesseracts and stuff like that. Thank you all so much for coming in. I really do appreciate it. I'm getting near the hour end, so I will be ending at about 4-ish, 4:05 maybe, if I could push it a little bit further. But I encourage everybody to smash that favorite button. Thank you for the favorites. There's a lot of, yeah, I don't know. Yes, everything's real. No, I have no idea. There we go. Let that pressure. out of there. The ballistics of bullets, gravity really changes the characteristics of a bullet. But do you know that a bullet fired horizontally and a bullet dropped from the same height will hit the earth at the exact same time? It's like gravity doesn't get affected. Like, it's only the time that you're affected by gravity. That horizontal flight that you're shooting a bullet, it's not really anything. It's just changing how gravity pulls on the earth. Breaks the speed of gravity? No. Gravity! I like that. Good name. It's like, that's what we are covering today, gravity. We are getting near the end of this topic. If there are any questions about gravity or anything in particular, just go ahead and shoot those questions, and I'll try my best to answer them. I know, right? It's like this was made for you to come in here. Gravity! Gravity always brings me down when I'm in a good mood. Why is that? I think you're looking about life differently, but I don't know. Friction and gravity. Yeah, friction and gravity. Ryan Higgs. How are you? Good to see you. Thank you for stopping by. Hold on. Make you a bouncer. There you go. Bouncer in my room now. And like, weight times mass equals force. Yes. No. I'm sorry. Weight is force. Weight is equal to mass times gravity. mg. Weight is equal to mg. Mass times gravity. So if you have mass times gravity, yeah, weight equals mg. Yep. And your gravity constant changes. Your gravity constant changes, but your mass stays the same no matter what. So if your mass is one thing on Earth, it'll be the same thing no matter where you go, because your mass is not dependent upon gravity. Okay, yeah, thank you for the roses. And thank you all so much for joining me. I'm Mike F. Bell, and this is Weird Science. If you haven't had the chance to smash that favorite button, go ahead and smash that favorite button. The moon makes high tidal waves. This right here is actually... Okay. Just did. I'll appreciate it. Yeah, thank you so much. There we go. I just hit you with a favorite. And just so you all know, anybody who spins those wheels and gets me the top gift will get in my name for 1 week. So what we got, the Octo Kraken, that's what it is, the Octo Kraken, whatever the gift is, Octo Kraken. Ping pong ball. Yeah, ping pong balls and science go well together. And what we got, let's see, what time is it? It is 4 o'clock. So I am at the end of my stream. So this is the perfect time to take questions and talk about what we did and hopefully talk about it next week. I did a science project in high school. It was really fun to experience different objects and their effects when there was pressure. Yeah, pressure is fun. What's up, Mr. Fukin and Mustache? What's up? Some white magnesium. It's like maybe in a future project. We'll see. What's good? How is everybody doing? I am getting to the end of the stream. I can't believe it. It went by like so fast. So easy to have. Time flies when you're having fun, I guess. Thank you so much, Mustache. I totally appreciate you coming in. I appreciate you all coming in. Thank you all so much for hitting that favorite button. And thank you all so much for tuning in. I will be here next week at Wednesday at 3 p.m. Eastern, 12 p.m. Pacific time. We'll be doing more science and fun stuff. So I hope you will tune in. It's in development. I'll have it on my Instagram for sure when it's ready. The Mike F. Bell bobblehead. Mike F. Bell bobblehead coming to you soon. Follow me on Instagram at Mike F. Bell, just like my username. And thank you guys all so much. What's up, Logan? How are you? Getting to the end of the episode. I can't believe it. It's like, thank you for the favorite. I appreciate that. Will it come with a science lab? Probably not. Probably not for liability reasons. So today we learned about gravity. And I hope you got some insights into the properties behind gravity and why it does what it does. We dropped things. We dropped hammers. We dropped different objects. And you know what? They all fall the same. We dropped a feather and we dropped a ball bearing at the same time in a vacuum chamber. And they fell at the exact same time. That's because gravity affects things exactly the same. While gravity is dependent on how much mass something has, it attracts everything the same. Well, thank you all so much for joining me. I am here and I'm done. My stream is over. So it looks like I will be seeing you next week. Thank you so much for coming. I will see you next week. Be sure to favorite me. Be sure to favorite me on or follow me on Instagram, Mike F. Bell. Send me some DMs if you have any suggestions when it comes to future experiments. I'd love to hear from you. Other than that, I will see you guys all next week. Thank you. I have a good week, guys. See you Wednesday.